Hello. So I thought I'd give a hand at implementing the standard error techniques for working with error codes, so we can add error handling into our maze if we so chose. So it's not required for the project, but I thought it was something good to know that in addition to exceptions, there's also a standard facility for dealing with error codes. So I'm going to kind of give my hand at implementing that. So I have my project here in my little Gitty instance, and it's all up in Git. So, oops, sorry. Maze 2. Status. So we'll go ahead and check out feature error handling. Okay. So the pattern I like to follow is a simple header file and source file that implement this facility. So a new header file, add to targets. Yeah, I guess so. It's a header file though, so yeah, okay. So this is just going to be our maze error. Yeah, go ahead and add it to Git. And like I said, I like the pragma once. And oops. And we're using the namespace CST. So namespace CST. Okay. Includes system error. Okay. We're going to build a enum for our error. So this is going to be an enum class maze error. And what's some of the errors that we can have? Invalid input file. We could have a invalid maze size. Anything we kind of want. The trick is, though, you're not allowed to use the value 0 because 0 means not an error. And because this is an enum, the default value of the enum is 0. So we need to make sure that this starts at 1. Another thing you can do is say not an error and kind of reserve that space, not an error, for that first one. I like to just be explicit and put the 1 there so that the enum starts at 1 and we're sure that 0 is not used. Okay. Now we need to implement a method that converts our maze error into a standard error code. So that's going to look like this. And it's a make error code. And it takes a maze error. And that's it. Okay. So that's our make error code. And that's kind of the whole interface. Now we need to tell the system error library that our enum is in fact a system error enumeration. And we do this with a little bit of template metaprogramming, which is kind of a big fancy way for saying template specialization in this instance. Template, so we're going to specialize this template. It is a struct, and this is what's called a type trait. So is error code enum CST maze error true type. Okay, so this is saying that at compile time, this library can determine that this maze error is a standard error code because it's that true type. So this is a little bit of template metaprogramming there, and that's how we do it. Okay, new source file. We're going to call this the maze error, and we'll associate it with both. that's fine. Okay, I just have this habit that header files go on the left and source files go on the right. Don't know why. Okay. Now we need to implement the error category. Namespace CST. The error category defines the domain, or the kind of context that goes with these error values. So we can carry around the very small integer that represents that error value, and then combined with its category we can decode it into strings to get messages. And we declare that this is a standard error category. Now what are the things we need to implement? We need to implement the const char star name, const, it is member const, it is no except, and it is override. Okay. We also need to implement the standard string message that takes a CST maze error, and it is also member const and no except and override. Non-virtual member function override hides virtual. Actually, this is not going to take our error code. It's going to take an int. So it's actually going to take the value as an int. And the reason is the error category provides that context, but it's going to float around the system without its context, and then it's magically going to come back together and get decoded. And this is the method that does that magical part. Okay. We need to declare one of these. Maze error category. Maze error category instance. And then we're only ever going to have one of them. And then we need to implement standard error code. Make error code that takes a maze error, E, and it returns a static cast int to our E and our maze category instance. That's it. So this is what combines, so this takes our error code with context, strips off the context, but then packages it with the context, and then lets it float back into the standard library. So then it can float through our code as a standard error code, and when we try and print it back out, it will do the right thing. Okay, so let's go ahead and implement these. Okay, you can implement them inline here as I'm about to do, or you can implement them separately. So we're just going to return, this is our maze error for CST. GCU. Okay. All right. And now we want to take our message and decode it into all of the different messages that we want to print out. So we're going to take a switch and a static cast to a maze error, and this is going to take an E. Case, this will be maze error invalid input file, return valid that input file is that. I cannot spell today. Okay. Case maze error valid maze size, return requested maze size is invalid. You know, maybe they passed in a negative maze size or otherwise. And then we have our default case, return unknown error code. This will probably never get hit, but we're going to provide it anyway so that when we crank up the compiler optimization, crazy things don't happen. Okay. That's actually the whole thing. That's all of it. So now we can start using this in our code. Let's make sure it compiles. Oh, we have to build catch. Okay. Okay, cool. So now we can come over to our little tests. We have our tests over here. Let's test some test case, test errors. So we should be able to make a standard error code, EC, from a ECL, CST, maze error, invalid maze. And that should compile. If it doesn't, we didn't hook up all of our little library methods correctly. Hey, it does. Okay. Let's go ahead and run all our tests. So cmake debug, and we have our tests. Awesome. Okay. So then we can take our test case, and we're gonna print a message. Print an error message. Okay. So we'll take our standard error code, EC, equals CST maze error input file, and we want to do standard cout. Actually, we're going to do C error because this is an error. Build it. Okay. Hey, look! It printed out our error code. That's so cool. Okay. Printed out the error code, and it printed out that the value was 1. Okay, cool. So that's our mechanism. Let's actually try and use this in our... So let's say that they passed in an initialized maze, and maze is now going to take an error code as an out. So code reference EC. This is an older style, kind of a C style of error codes, but a very popular one still, of passing in a value that can be set. Okay, and let's just say if h is less than 0 or h is less than 0, return EC equals CST. We're going to have to include our, include maze error, CST maze error, invalid maze size, return nothing. Okay. So let's see if that compiles. Let's see if empty initialization list will make an empty maze. It does. Okay, cool. So then, wait a minute, did that actually compile? No. Okay. I don't know what this is actually compiling. Okay. So we need to fix the initialize here. So this is going to take a standard error code EC. Now notice we're not actually specifically calling out that this error code is a maze error category. We're not calling out the domain. That's all going to get worked out by the library. That's what that little template metaprogramming piece did for us. Where did it go? This guy. That's what this guy does. This guy hooks that up and makes that context kind of just work. So we're going to pass this. So if EC, then we're just going to return -1 because our maze exploded. We're going to do a standard C error, EC, and return -1. Okay. And we should be able to compile this. Okay. We should be able to make a test for this. So let's copy this, go over to test case maze initialization. Okay. So this will be the happy path, and ooh, none of this code is in. Okay, so we're gonna have to make a main.h new. Oh, but we can't. Okay. So I will refactor that offline. Because that's going to be a lot of work, so I'm not going to do all that right now. So let's just change this right here, like that, and see what happens. Standard length, core dumped. Okay, initialize maze should have returned standard error code. If standard error code, then return -1. Oh, ha! So we actually completely avoided this problem because we used an unsigned type here. So let's just say if it's equal to 0. So this value can actually never be negative. And I bet if we, actually this is a great lesson. Let's crank these up. How do we add errors? Let's see, set cmake cxx. How do we set the warning level? Cmake set warning level. CXX flags. Okay. Cmake CXX flags. Now, a good one is wall. Okay. Great. So there's one of our warnings. Now there is this, let's see, what was it? Lefticus. C++ best practices, tools. This is great. And use the tools available. I think warning levels are in here. Yeah, there they are. There's the warnings that you want to use to make your code nearly bulletproof. Well, as bulletproof as the compiler will help you. Bam. So, all warnings with extra warnings, shadow warnings, non-virtual destructor warnings, and pedantic. Okay. Make. Aren't I using the Clang compiler? There we go. Okay. Awesome. So, here's where the compiler's actually helping us. Comparison between unsigned expression is always false. So we were comparing this thing which is unsigned to less than 0. It'll never be less than 0 because it's unsigned. So the compiler could have caught this error for us if we had high enough warning levels. So let's just say if it's equal to 0 or if h is equal to 0, then the maze is an invalid size, right? So that should actually compile. It does. And if we do a maze, oh my gosh. We need to pass this as 0. And maze. And we got a maze error. So now what happens if you do try and pass that in as -1? What does that actually do? I don't know. Let's print it out. Okay, I bet you that is max value. So if, I think it's limits. standard max size t oh, we're never going to find it in here. Okay. C++ limits. C++ reference numeric limits. Oh, it's numeric limits. That's the library I was looking for. Numeric limits. Okay. Not this one. We want numeric limits. Oh, which is in limits. Okay. Numeric limits of size t and max let's print this guy out too. Okay. Changes back to W. Yep. So if you pass in a negative value, it actually truncates up to the maximum size of that thing. So we can actually check for that now. So we can say if the maze is equal to W, or 0, or W is equal to size numeric limits. And you can kind of check for that value too if you wanted to. Make maze, and we get our maze error. No longer get that nasty little default. So that's kind of how they work. That's standard error code. The thing to remember is you have your error category. You make one and only one category instance, a little function that converts between your error codes and integers. You actually define all your little error codes, the messages for those error codes, and then a little template metaprogramming to connect your error code up to the standard error code enumeration. And there you have it. If error code means if something bad happened, do bad stuff. That's it. All right. Thanks, everybody.